come to the end of the inaugural session. So we'll be starting the day with the keynote address by Professor Sivakumar from IT Bombay. Sivakumar is a professor at the Computer Science and Engineering Department at IIT Bombay. His research interests include various applications of logic in computer science. His current focus of work is on formal verification of safety critical real-time systems, for which a center has been set up recently at IIT Bombay. He has guided a number of PhD students under him and has a number of publications. He is a big fan of GNU or GNU Linux and free software, and along with IBM and CDAC, he has helped to set up the Mumbai, the Open Source Software Research Center, OSSRC. He has given lectures on internet security and cryptographic protocols under the IEEE Distinguished Lecture Program at several universities in Australia and New Zealand in the year 2002. Thank you, sir. Now it's
Thank you very much, Balaji. Very good morning to all of you. Faculty members, professors, we are used to speaking in 55-minute chunks. A lecture starts, 55 minutes later the bell rings and we go out. So he has said I should stick to the 30-minute time interval that I have been given. I will definitely do that once we can get the slides on in the screen. So I have typically in most of my talks I do this, split it into some, you want to, we had tried this once and it worked, so I am sure it will work again. Function effect. Yeah, so we are on. We're almost on.
resolution.
Not this, we want not the Acrobat Reader, we want the entire screen, the display.
This is an extended version.
Yeah. Control L, full screen. Yeah. So thank you so much. We had tried this in the morning, it worked, so now we are back to normal. Okay, so many of you may know that Good, Bad, Ugly was a movie, Clint Eastwood, quite some long time back. So in this keynote I usually put this good part first, which is actually going to take less than 5 minutes because it is something you all know, but it is to set the stage. And then comes the bad and the ugly. And although the focus of today's conference is on banks and financial sectors, I have taken challenges for PKI which are probably much harder than what we already heard about in the morning, and there is a reason for that. I do not know, many of you may have been in group photographs, when you stand in a group and they have to take your photograph. So how do you make yourself look good? Choose a correct neighbor. So the PKI problems you heard about in the morning for the banks will seem much less when you hear about what are the challenges for IoT, Internet of Things. Of course, challenges are also seen as opportunities. So I will say, this is actually in some sense slightly removed from the main focus of the theme. And the second part also, is a way of what you want to see the glass as, half full or half empty. So I am going to shake a little bit of confidence, not because it is the correct thing, but just as a posture that the centralized certifying authority system itself is being challenged. Do we need a centralized model and trusted third parties, or are there ways of doing public key infrastructure which is decentralized? Now, none of this is going to happen in the next couple of years. And of course, in India, it might take a little longer also. But therefore, in the keynote address, I have taken the liberty of going a little bit one step back. And I'm sure the rest of the day will be focused on solving the problems for the banks and the financial sector and the signatures and so on. But let's spend about 20 minutes listening to these three parts. So that is the goal. And of course, I have also put that palm figure just to say that reading the future is very hard. And the rate at which internet and technology changes, which is the first part, the good part, you will see that some of this may technically be overtaken by other solutions. So we will, with that disclaimer, let's move on. And just one last slide, this is I put in almost every talk, all of you know this, Andha Gajanyaya, blind men, each one looking at an elephant and coming out with his own understanding. This field is also somewhat like that, but today of course the focus is on banks and financial sector. And of course I also know that even in banks and financial sectors, talking about blind men or one-eyed men is not really so good these days. But what I wanted to say here was that the focus after this in this session will be on one part, and this keynote address may not directly focus on that, and we will, with that disclaimer, move on. So very quickly, internet is a very good thing, and up to 1995 to 2005, we can call it Web 1.0, where the browser made it very easy to access information, and search engines helped us to find out the information that we want within quotes, because when you search in Google for what you want, you get so many hits and you don't know which one is the correct information. You have to go through a little bit of manual effort is still involved. So we'll call all that as Web 1.0, and from early 2000 till last 5-10 years, we will call it as Web 2.0, where Facebook and Wikipedia, Twitter and all those collaborative applications have enhanced the power a lot more. So we will call this right to assembly collaboration. You don't need trusted third parties, that thief is coming again and again. Okay, so, but it has also got its own problems, unreliable information, contradictory information, and we still want to claim that this is not the evolution, end of evolution of internet. There is a Web 3.0. So what is the dream that you would like internet to have? So this is where we want artificial intelligence to meet open enterprise. So I'll just maybe tell a 2-minute dream and then you can tell me how it is going to work. So when I wake up in the morning, what should happen? Some of you have heard this. I should put on a computer, insert my token, put my fingerprint, and then log in, type some complicated passwords, and then click on the site I want to. Is that what you want? What do you want? Automatically, the radio should start playing the channel you want, and the voice should come and say, wake up, and it should say all the nice things. Tomorrow is your wedding anniversary, your wife likes this color sari, this is on sale there, shall I buy it and get it shipped? And then dinner, can I book this? Who should tell all this? The computer. And how does the computer know all this? So that is where we are heading, okay, that you are able to generate information about the user and about the world through agents or intelligent software which have to trust each other, which have to verify the information, which have to give correct answers, should not be telling all wrong things. Okay, with that circumstance, we will see what happens. So I have just given a URL where they have said what are the 2016 technology trends. You don't have to go through each of this in detail, but financial services they have said. Similarly for transportation infrastructure, news, and everywhere you are going to find words like this: intelligent cameras, Internet of Things, smart assistants, ambient proximity, interfaces. So these themes are affecting every aspect of life. So let's just spend a few minutes focusing on that, what it means. So this is something that is no longer just in the labs, wearables they call it, your glasses, your watch, everything is going to affect your life. In what way? Why should a watch, in what will the watch do? You have heard of watches that can count how much you walked, how many steps you climbed, how much calories you burnt. It is measuring all that in addition to doing its duty as a watch. And what will it do with all that information? So that's the reality we are looking at, where all this information is now transmitted to the right person, not your wife, but your, but your doctor, who will then say, don't do this, eat this, your blood pressure will be monitored, your things will be, pulse will be checked, any alerts, alarms automatically be reported. So we can extend this, right? So I'm not going to, in the interest of time, tell all this. And it will take all this data and hopefully impact our life positively. Trusted information, all this is coming. You have to communicate, you have to trust, you have to know whom you're talking to, you have to have privacy, all the issues that are going to come in banking transactions. So it's just that the domain is slightly, a little bit different. So the last part, last slide on the good, last slide with 5 parts, that we are now going to what's called third platform. Mainframes and computers was first platform, terminal, mainframe and all that. Second platform is client server. You have a nice PC with browser and all these fancy applications, Java, everything. That is second platform. What is third platform? That is what I'm going to talk about. The 5 things are SMAC, SMAC, and IoT, Internet of Things. So many of you may have heard these abbreviations. S is for social, that no longer you can live in a what do you call it, in a remote ashram or a monastery or a cave in the Himalayas and realize yourself. Today every aspect of our activity is affected by social interactions. And how to trust, whom to trust, which news is correct, which article to read, which movie is good. How do you know which movie to watch? Facebook likes, Twitter, which articles come to the top, what are those likes? Do you really trust those likes? Or do you trust the review that is written by a journalist paid to write a review? So you have to make these choices, okay? And they are happening. Crowdsourcing. Wikipedia, do you trust more? Yes? A lot of people have seen it, made changes. Now crowdfunding also. Banks are not funding many of the people who are good. So instead of venture capitalists, anyway. So this is one aspect. This is social, is coming in every part. Second is mobile. And this is where I think the PKI people have to, if you are looking for the market, what people are saying is that computers are also going to become legacy. Like mainframes and terminals became legacy. And everybody is going to use only this for 90% of what. Everybody means not there are always specialists who need it, others who need it. But the general public will be using a mobile, a smartphone. And on that phone, they will not want to do everything common for everybody. When I read an article, everybody should not be reading. If I read newspaper, I have a Hindu newspaper here. Everybody is seeing exactly the same version of the article. Is it possible that I can have an internet of me, that in my mobile, I only get a version of Hindu which has articles that I like, or I'm interested, not like, which I'm interested in, written by people whom I trust, and written the way that I want. Some people may want a bottom-up approach, lot of data, and then some people may want the other way, top-down. So can everything be customized? Similarly, advertisements. Similarly, what I want to purchase, what I want to do. Okay, so this is the M part, Mac, mobile. Then the analytics, which is in the back end. To make all this happen, you need to process all the big data, understand the person's thing, and so on. In the interest of time, I'll move a little faster. And that is done by a cloud platform, so that computation is not very costly. This mobile cannot do much. It cannot put your hardware token. It doesn't have a USB port. So I cannot do digital signature today on this. There are other ways, of course. There are ways around and there are solutions for that. But cloud is the enabling platform behind that. And e-sign possibly is one thing. Aadhaar-based signatures is another thing. One-time signatures. Because as an end user, it's not necessary. What can be put on the platform as a service? And that is the last line that I want to just focus on for a minute. All of us know what is IaaS? Infrastructure as a service. Platform as a service. Software as a service. So signing, it's not signing as a service, it's software as a service. Signing as a service is coming. That when I want to sign, I will sign that one time and pay that amount. And it can all non-repudiation, integrity, everything. It's PKI only, but not done through hardware tokens and so on, through some service. What is CAAS? Crime as a service. So this is why I am saying that PKI, the way I am talking sometimes it looks like it's not, I am not, it is needed, it is a must. Trust, confidentiality, integrity, non-repetition, this will never go whatever you do. Okay, and today crime as a service is forcing us to rethink all this. When I was doing good, I want to say only good things. I am going to come to the bad very soon. And therefore, the next and last thing is this Internet of Things. So Internet of Things means what? This smartphone is not just one thing, it has so many things inside. It has a GPS, it knows where you are, it knows motion, velocity, are you moving or not, and then it can have many other devices also. It can have fingerprint, it can have a pulse measurer, it can have so many devices in it, and these things are going to communicate with the environment. When I walk into this hotel, if my phone can tell, in this hotel this is happening, that is happening, dosa is given free today, go to that room. It should not tell whenever I am in some IIT, because that's no use. So it should know what is relevant to me, where I am, which information, and also the time. Am I interested in eating, that sort of thing. So the Internet of Things can do all that. Okay, it can, and here is a use case. Again, in the interest of time, I will not go deep because this is just a flavor. This is the open enterprise part. So here is a borrowed example with some modification of what could happen. Google Calendar, we all are familiar that you book an appointment or a meeting or today's talk. When we got PDF files, but we could have got something which we could also have edited and changed. So there today lunch, I don't know, CDAC is giving, no? Is it same lunch for everybody? Yes, no? But is it possible that each person could have in that form filled, I want South Indian vegetarian, I want this, I want tandoori, I want that, I want that. Who will bill? Don't worry. No, banks are here and NPCI will pay. The idea is that for meetings like this, for 3-4 individuals, you can all before the meeting say things like this on a Google Calendar, which will then get the Pizza Hut will get one order, this will get one order, the delivery boys, the Ola cab will then pick up this and give it there. And this happens, your meeting is at 3, at 11 o'clock in the morning, you're doing all this information. At 3 o'clock when you go for the meeting, all that gets delivered by a drone. It's a traffic jam, no? So, now all this is done by one company. Microsoft wants to be that one company, Google wants to be that one company, but we know it can't happen like that. Okay? Therefore, that is the meaning of open enterprise. So what is really happening? That all this information is being shared. Each company is partnering with many others, and their devices and their computers are importing and exporting APIs or data through APIs and providing services which they have to then share the cost. Because I pay only once. I mean CDAC. CDAC pays only once. But then every person who made this happen, Pizza Hut, Fasos, this fellow, Ola Cab, everybody gets their share of the money through a trusted transaction, which is verifiable. So this is what we need. We need transparent inference flow, consistency, end-to-end security. And in security context, this means even that the machine-to-machine messages, when Pizza Hut computer told that fellow Ola Cab come and pick this up, no person is sitting there and making phone calls. Okay? And that record has to be then billed, analyzed, proved, verified in a court of law dispute, all those sort of things. How will this happen? How will PKI work on internet? That's where I am coming for the second part. So this is the good part, that if all this happens, is it good? That's the next question. Are we getting life is becoming too mechanical or too personalized? So there, I think people in this room, from what I can see, their children will not agree. Okay, what do you think is right and what do you think is the way to do things, what do you think is the way to learn? The next generation is not going to, they will not go to a bank. They will use a Paytm or they will use they will not open an account. They will not put FDs. I'm sorry, I'm just guessing, okay? I may be wrong, but this is part of the thing. And you have to then see what it is. So coming to the security concerns in IoT, which is much bigger challenge for PKI, is that, see, I already said that IoT means it also includes smart homes. Smart homes means your fridge has sensors and computers and TCP IP, and for what should a fridge have all that? Why should a fridge be sending messages and getting messages? So if your milk is not there, egg is whatever, bread is not there, this is not there, it knows intelligent, it can then place the order. So when you come home, the delivery happens, all those sort of, you can imagine for everything, tube light, any appliance in your house, you can see the reason for being able to communicate with manufacturer, firmware or shop, or that's the other thing. It is not one, that is it is going to do with lot of things. Smart grids means what? Cars are all driverless. Google is saying that you won't need a driver. Today Google it is telling go 100 meters, take a left, at the side move a right, all that you have heard in that Google Maps. It is saying if I have to tell you all this, I can drive the car myself. Why should I tell you go 100 meters? I can go 100 meters. Provided it avoids collisions and all that, but that is no longer lab, they are doing it actually. So driverless cars means they have to then find the best route, they can give way to each other, the planning, traffic, everything at a higher level we don't have to do through static systems, but intelligence which is dynamic can control the electricity distribution, smart grids. Then in the human body also, lot of devices, they are saying personalized medicine. Today we say blood pressure has to be between this and this. That's actually not true for every human being. Each person has his own range of what is good, what is bad, and if we can then have devices which are customized to measure for you, not for the general person, then it is better, same thing. So the point is that there are threats. If you want all these good things, if you consider them good, then all these bad things can happen. The fridge can start ordering junk food and you are not deniable anymore because your fridge ordered it. It has been signed by PKI, private key. You have to pay the guy and you don't want to eat that. Similarly, in your kitchen when the devices are on off, you want coffee ready, so you program your microwave to start heating the milk. When you come home, coffee is ready. You can see a fire coming. Not because of malfunction, because of a hacker who has broken the key or done something and made it misbehave, not because of equipment malfunction. I want to kill somebody, I just start increasing their heart pacemaker, I send messages, or I inject insulin or whatever. Okay? And then driverless cars take you wherever they want to go, not where you want to go. And then drones, instead of delivering pizzas, they can come and do what they did in Pakistan or Afghanistan, just kill people. So this is a fertile territory for hackers. And unless you have PKI enablement in some sense, IoT cannot succeed. PKI is one of the best solutions available for providing all this security. But PKI has to change. Why does it have to change? Scale. We already heard some estimates after so many years, 13 million certificates and so on, so many users. Okay? And in the world over, if my data is right or from the sources I got, there are 2 or 3 CAs who have 80% of the market share. Verizon taken over by Symantec seems to be in the top and a few others. But I don't know, most of you may have heard of this bullet, that let's encrypt. Do you know what that is? Free, okay, no payment. Automated, no application, no signature, no signing, open. Any website, can get a certificate, trusted by all browsers, and their goal is to encrypt 100% of the web. They are still PKI, and in September last year they started and they've issued 1.7 million certificates in the last 8 months. Okay, so this is something you should, if you have not seen, let's encrypt, you just search for that, you can find out. But anyway, that is still the traditional one, the websites, the SSL, the traffic on internet between firms or individuals, that sort of thing. But what Gartner is predicting is that devices is going to be in billions, not millions, several orders of magnitude more. Okay, when the Internet of Things are made and such devices, smart devices are sold, therefore to scale your PKI to this, can a few organizations provide this? What type of computing facilities they will need, what infrastructure they will need? Then comes the diversity, that you cannot mandate everybody should get a USB token. Everybody should have a software that can compute some things, or to be in a slightly more cut closer to the bone, everybody should use Microsoft browser, Windows 7, 11, this browser version, otherwise you can't sign. So all these things are going to be different for different devices. Okay? And there is a power energy range, transmission range, how to pass the messages. You must have intermediaries. It cannot directly be in the endpoints. End-to-end security, PKI provides. Whether what happens when you have multi-hops. Okay? So that is diversity. And then comes this issue of identity itself. In most of the transactions that traditional PKI is talking about, we have an identity, you just have to prove that you own a particular domain name or you own a PAN number. And then you sign. But it's not like that. A phone is not a single device. A phone has a camera, it has a speaker, it has microphone, it has other sensors, and once I may be able to allow others to access certain parts of my phone. Have you installed apps in Android? Do you always say yes when it asks, shall I use your camera, shall I use your this, you always say yes? Accept all. Why? Because you want that application. So you have to be careful. But what I am saying is that you can have some applications access only your location. Some applications access only your images. Some applications access only parts. Each one then needs a proof, and the proof is not for one certificate for one phone. You have to know which ones you are allowed to do. Again, we all know that when you do authentication, it is usually based on one of the three factors only. What are the three? What you have, which is the token or secret, what you know, which is password, and devices can't know passwords, they can't set passwords. What you are, we have biometric, we have vision, we have a face, image, voice. Devices don't have this. So this is another challenge. Then there's the context based authorization. Where am I? I allow certain things when I am in office, don't allow it when I am at home. I want the owner of the device to do ABC, but I want the manufacturer, he may anonymized data we may want to tell. If you are, for instance, manufacturing tractors and you want to know how many are used in South India, how many are used in North India, you may want to allow manufacturers to access such data anonymized. So the PKI certificates attributes are much more complex to manage. Okay, and the government may mandate that certain fields should be knowable if you want to use devices like that. And this leads to the problem of key life cycle, how to manage it, who are the user roles, local namespace, should you allow a company to control hierarchically a node to control all devices below it, or do you want that method, you understand? That Cisco, for instance, Cisco routers, they will do everything for you. Okay, but if they have to interoperate, that is the first one. If you use an RFID tag on an international parcel and you are shipping it to some other country, then you cannot say this RFID is made only by that guy, it will work only in India, it will work only in Tamil Nadu. You have to make sure that it is able to exchange data and conforms to standards and interoperates and that sort of thing. These are issues. So again, no solutions. I am just telling you some of the things to make today's rest of the sessions look much simpler. The challenges you face today hopefully will look much simpler. So now my last part, just to stay within the time. A slight shift in focus. Earlier we were talking about scale, complexity and difficulty of implementing PKI for Internet of Things. With the, let me reiterate the message that PKI is a must, it is needed. We cannot do without it. Only thing is it has to face a lot more challenges when it comes to Internet of Things than when it comes to individuals doing financial transactions. Now the next step is again not dispensing with PKI. The PKI and its technicalities are needed. What we are attacking now, not we, not me, what some people are attacking or what one area of work is that we do not need trusted third parties. So you have seen this in other domains. Media, all of you, do you trust mainstream media now or social media? So that's a debate, you can go on. Similarly, when you do distribution of music and so on, do you want iTunes or do you want peer-to-peer? I'm not talking about the legal aspects, even legally. Do you want a closed ecosystem or do you want an open system where a song produced by one company can be played in another player, or a video produced by some other, or you want to lock it into a particular device and a format with distribution rights, digital rights? I'm not taking sides, I'm saying these are issues. Similarly in PKI, whether we want to go the trusted third party way or whether we want, or is it possible at all to remove that dependency on a centralized, and the answer seems to be yes. That no centralized trust, and here I have given a paper which you can search for, it's not a very detailed paper, but 10 risks of PKI. This Bruce Schneier is a security expert. So you can search for this and you will find out, he has explained in detail that the CA, what is the CA an authority on? We say authority, no? They give me a certificate, do they know that I am a good guy or a bad guy? Do they know I am a criminal or not? What are they certifying? And we are assuming that they are certifying the legitimacy and legality, that is not at all what a certificate is telling. It says that he owns this. Okay, and owning a certificate does not give me credibility or trust. It's part of the process, and therefore it can be compromised in many ways. And more important, there are now so many CAs and sub CAs, okay, and even the way we do it, our email ID, just because I have a Gmail ID, am I trusted? Or a Rediff mail ID, that's not mine. Actually, I am renting it or hiring it from a third party. Domain name also. My home page can be in some other domain. So trusting a domain doesn't mean trusting the pages in that domain. So to that extent, what we are saying is, why centralize? Why not have a system where the owner controls the identity? I do not get a certificate from somebody else. It is a self-certificate, which can be verified, which I cannot repudiate. Suppose I say this is my key, this is my certificate. I don't need a third party to endorse it. Is the message, is it clear? But I cannot also deny it. I can control the identity, but others provide auxiliary services which ensure that all the other properties you need for the certificate are respected. So then let me explain a little bit more what that means. Bitcoin, you have heard? So currency is presented by RBI, RBI is here. Today they are saying, why do we need RBI? Why do we need Federal Reserve? Why do we need currencies to be printed by trusted third parties? Anyway, the value is going down. I'm just kidding. So the Bitcoin system is successful. It provides the technology for people to earn money without a third party issuing money. Everybody knows what you have learned, no double spending. Proof of work is establishes that I own it. I cannot spend the money again. Everybody can verify whether I have that money or not. Identity is secret. Transactions can be done. I'm not going to explain how it works. All I'm going to say is that this is achieved by using what are called blockchains. At the heart of Bitcoin is a technology called blockchain. And blockchain is a consensus protocol that everybody, like Wikipedia or crowdsourcing, agrees that this is the state of the world. And nobody can change the state of the world. You can contribute, you can do your part, but you cannot alter, you cannot change somebody else's certificate. No man in the middle attack, no certificate pinning and all that, solutions to that. So we have a digitally signed transaction proof of work which is non-repudiable, which is also accessible to everybody. There's a consensus, everybody agrees this is owned by him, this name is owned by this. So this is what is called blockchain for PKI. That PKIs can be generated, self-generated. You can generate your own certificate and you can put it in a ledger which is trusted, verified, provable by everyone, and nobody can compromise that. Such implementations then allow clients, including thin clients, to verify, because that is what is the thing. We have to verify the signature, you have to verify. All those also are provided. That owners can register, update, look up, revoke certificates, and clients can do the rest. They can verify whose key is what, whether a key has been revoked, what are the attributes of the key. And in one word, if you want to understand how this is possible without keeping the entire history or huge amounts of data, it is called Merkle trees. That is, if you keep the information in a tree-like structure, then each part will contribute to the root hash, the topmost level, and therefore any change in any part of the tree will be detected by just checking the topmost root hash. And if the root hash is okay, then each part can be verified independently and separately. So the clients then do not have to have very heavy weight infrastructure. Now this is not a success, this is not proven. This is where the world seems to be heading. It might fail, but if it works, then what I said, a mobile device can then create certificates, sign, trusted transactions, machine-to-machine verification, single version of truth, no man in the middle attack, many good properties are there. So as a research problem, if somebody wants to do PhD, please come and apply in IIT Bombay. I also want students. Yeah. So my last slide, and I hope I have not overshot too much. This is a quote from the PKI forum, which I should also compliment that first video that CDAC and CCA put in the morning was extremely good, and I hope you have Hindi versions and Tamil versions, and the voiceover was English. Do you have another other? You should do that. There was a video explaining how PKI works and what properties it has. So this is definitely achievable, and therefore I again want to say that if my talk sounded very negative or saying that things are very difficult, that was not the intent. The main message I want to re-emphasize, that the trust is established, and PKI is the best mechanism to establish trust. The non-repudiation, the integrity, the confident authenticity. The only question is, how do you manage the keys? Who generates the keys? What is a key? How does it work on other devices? How does it work on machine-to-machine communications? What are the challenges and solutions? But until we find those solutions, today's solution has so much scope, and like I said, you should look at the glass filling up. And I see from the excellent program today that you are going to hear from bankers, you are going to hear from central bank, you are going to hear from other financial segments, and you are going to hear from certifying authorities and so on. So again, on behalf of CDAC and others, I thank them for first giving me this opportunity to give my thoughts, and also wish you a very interesting and productive program. Thank you so much.
Thank you, sir.